Hi guys, in this video I'm going to talk about conditional probability and independence. Okay, so if you're new to probability, be sure to go back and watch some of the more basic videos where I do lesson 1, 2, 3, that type of thing. Okay, basic concepts, events, sample spaces, so on. Okay, so I'm assuming that you understand all that stuff. We're going to go forward with these slides. So conditional probability basic motivation, basic concept is that the knowledge that a certain event has occurred can change the probability that another event will occur. Emphasis on can change, okay? So its notation is, and it's read many different ways, but written like this. This is read the probability of A given B. Another way to say it, a little bit more of a mouthful, is the probability of A conditioned on B. I like A given B. A given B. Okay, this denotes the probability of event A given that the event B is known to have occurred, stressing that. Okay, this is called conditional probability or a conditional probability. Okay, so let's take a look at the formula for conditional probability, or the relationship with other types of events and compound events that we've talked about. So let A and B just be any two events. One little caveat is the probability of B must be greater than 0. Okay, usually not an issue. The conditional probability of A given B is written like this, as we've talked about. More importantly, the relation with the intersection and the marginal. So the probability of A given B equals the probability of A intersect B. So remember, that's A and B. Those are outcomes that are in both A and B, over the probability of B. So be very careful. The denominator is the probability of the conditioned or the given event. Okay? Or of the condition, not the conditioned, of the condition or given event. All right? Okay, moving along. Independence, very closely related. Independence specifically between two events. Two events are independent if knowledge that one event has occurred does not or will not change the probability of the second event occurring. Okay, interesting. Does not change. All right? We just talked about in conditional probability the possibility that an event occurring can change the probability of another event occurring. This is saying that two events are independent if the knowledge that one has occurred does not change the probability of the second occurring. Okay, that's interesting. So you see the relationship between independence and conditional probability. Now, how do you check this? Well, there are a few ways, and I list a few of the ways you can check. Any one of these is sufficient on its own. Oftentimes, one is going to be easier to check than the other. Okay? So there are a few equivalent ways to check. That's what we mean by equivalent. To check if two events A and B are independent. Any one of these is sufficient, as I just said. Okay? So let's just think about this for a second. Just take one of them. Probability of B given A. Let's jump to that. This thing that the probability of B occurring given knowledge that A has occurred equals the probability of B. Think about that for a second. If I know that A has occurred, which is what this is telling me, what I've underlined, and that does not change the probability of B, in other words, it just equals the probability of B, then A has nothing to do with B. Another more correct way to say that is A and B are independent. Okay? So this is one way to check, this is another, this is a third, and there are even more. All the permutations of these can also be checked with their complements, but this should be sufficient, okay? Now moving forward to an example. So maybe you could pause, read, or I'll just read through just to clarify any maybe confusion. There are two companies. They produce emergency switches. Some of these switches are defective. Some of them are not. We purchased 25 of these switches, and we find the following about their defectiveness. And I've organized this in what's called a two-way table. It's not really important at this moment. So I've listed the two companies here, and whether they're defective or not here. This is just a totals column. This is just a totals row. In fact, we call these two that I've circled here marginal totals. Okay, this is the margin for the rows. This is the marginal total for the columns. Okay, the actual table here is just 2 rows by 2 columns. Okay, so this is a 2 by 2 table, incidentally. Okay, with margins on top. All right, and then I ask for the probabilities. All right, so work through these. You're going to use these numbers. Some of these are going to be very simple review type questions, basic probability, and then some of these are going to ask you for compound events and then eventually conditional probabilities. So pause, give this a shot, then let's take a look at the worked answers. So now looking at those worked out answers, we can see the results. You can check them against your work. Okay. Final results, very interesting. We're asked if the events were independent, that some of these events that you've made up here, and I checked using the multiplication rule, and I saw that the probability of the first event times the second event did not equal their probability of their intersections. Therefore, the two events are not independent. I used this way of checking, the multiplication rule. Okay? All right, so I'm going to stop this one here. I'm going to continue with the next lesson on Bayes' theorem, which builds upon conditional probability. So till next time, be sure to like, share, subscribe, and have a great day.